So the next video that we're going to talk about, or the next lesson, is going to involve how to use a matrix to solve a system of equations. Now we're going to do this for two separate lessons. Today I'm going to show you how to use a matrix to do the problems by hand, and then the next class we're going to learn how to do them using the graphing calculator. So everything that you see today you're going to be expected to do by hand. So the first way that we're going to solve a system is by using an inverse matrix. So the first step of the problem when you're going to use an inverse matrix is to write what's called a matrix equation. Your matrix equation looks like that, AX equals B. So what we're going to do is take this system and we're going to write it as a matrix equation as the first step. So the first step is to take and write AX equals B. Now, when you're writing the matrix equation, each of these letters stands for a separate matrix. Matrix A is going to be what's called your coefficient matrix. So all of the numbers that are in front of X and Y, they are going to go in a matrix all together. So 4, 1, 3, and 5 become what's called your coefficient matrix. That's your matrix A. Your matrix X is always your variable matrix. There are two variables in this problem, X and Y. And matrix B is going to be your constants matrix. So whatever numbers are on the right-hand side of the equal sign, those get written in a matrix together. So all we've done in the first step is take the original system of equations and we wrote it as a matrix equation. Now, once you've done that, you are now in step 2 going to find the inverse of matrix A. That's a process and a skill that we learned how to do in the last video. So this here is matrix A. So if I want to find A inverse, there are steps that have to be followed. The first step, I have to find the determinant of this matrix. So remember, finding the determinant means that you're going to take the first diagonal and multiply, you get 20. Take the second diagonal and multiply, you get 3, and you're going to subtract the values. You get a determinant value of 17. You're then going to take 17 and write it as a fraction, and you're going to switch the order of your diagonals and numbers. So remember from the previous video, the 4 and the 5 switch places. And the opposite diagonal, the 1 and the 3, they don't switch places, they just become the opposite sign. If I distribute the 1/17 into the matrix, I get the inverse of A would be 5 over 17, negative 1 over 17, negative 3 over 17, and 4 over 17. So that is the inverse of matrix A. In order to solve the system, you are going to take A inverse and you're going to multiply it by matrix B. So we're going to rewrite the matrix equation in the form X equals A inverse times B. So X equals A inverse times B. A inverse is the matrix we just found. So 5 over 17, negative 1 over 17. Negative 3 over 17, and 4 over 17. We're going to multiply that by matrix B, which is your constants matrix. That is your X equals. Remember, this is the variable matrix, so that's actually X and Y equals the product of these. Now, this is just a matter of doing the matrix multiplication. Again, a skill that we learned in the last video. So the first thing you're going to do is realize this is a 2 by 2 and a 2 by 1. So my result matrix is also going to be a 2 by 1. So I'm going to put my two spaces that I'm going to fill in, and we're going to go row by column. So row by column, 5/17 and 10 is 50/17. We're then going to add to that negative 1/17 times negative 1. That is 1/17. Second, we're going to do the second row and this column. Negative 3/17 times 10 is negative 30/17. And 4/17 times negative 1 is negative 4/17. So what you might be thinking to yourself is, wow, that is really gross. How am I going to get a nice, neat number out of those answers? Well, look at the numbers. If I add 50 and 1 together, I get 51. 51/17 reduces to a nice neat number of 3. If I add -30 and -4 together, I get -34. -34/17 reduces to a nice neat number of -2. So there are my answers for x and y, which means that my ordered pair solution is just the ordered pair 3, -2. That is how you solve a system of equations using an inverse matrix. The second method that we're going to talk about is using determinants. A determinant is, again, a skill that we learned in the last video. So there are two kinds of systems that we're going to solve using this method. We are going to solve a 2-variable system and a 3-variable system. The 2-variable is very straightforward. So here's how we're going to do this. The first thing we're going to do is we're going to set up 3 different matrices. These matrices are totally determined by the numbers in the system that you're given. The first matrix, matrix A, is your coefficient matrix. Look at the entries. A, B, C, D are just the numbers in front of x and y. Your second matrix, notice that the B and D column didn't change, but the first column did. The first column becomes whatever your constants were. In matrix C, notice we go back to the original first column, A and C, and the second column is what changes, and it changes to the constants column, E and F. All of these are going to be numbers. So how do I use Cramer's rule then to do the problem? You're going to find the determinant of every one of these. Remember, when you see a matrix with what looks like absolute value bars around it, that means find the determinant. So in order to figure out what numbers to put here, you're going to have to find the determinant of each one of these. So as I go through it, we're going to do where we multiply and multiply and subtract. Multiply and multiply and subtract. Multiply and multiply and subtract. So what I'm going to do is do a 2-variable example, and then we'll come back to the 3-variable. Now when I do the 2-variable, again, the first thing that we're going to do is we're going to write down 3 different matrices. The first matrix I'm going to call matrix A. That's going to be just your coefficients. So if I use my coefficients, they are 2, 1, 5, and 6. And to find the determinant of A, we're going to multiply the diagonals. So if I multiply and multiply, 2 and 6 gives me 12, 1 and 5 gives me 5, and if I subtract them, I get 7. We then are going to do matrix B. So the first column, the 2 and the 5, they change. We're going to make those now our constants, 3 and 4. Our second column stays the same, 1 and 6. And what we're going to do is find the determinant of B. So if I cross multiply my diagonals, the first diagonal gives me 18. The second diagonal gives me 4. If I subtract those, I get 14. We then are going to set up a third matrix and do the exact same thing. My first column goes back to the original, 2 and 5. My second column is what changes now to the constants, 3 and 4. So if I find the determinant of C, we're going to multiply and multiply. So the first diagonal gives me 8. Second diagonal gives me 15. And if I subtract, I get -7. Now, once I've found all of these different determinants, what do I do with them? All you're going to do is divide. You're going to take the value that you got for determinant A, and you're going to divide it into both of these. When I divide B by A, 14/7, that gives me 2. That's my value of x for my system. When I divide C by A, -7 divided by 7, it gives me -1. That's the value of y in my system, and all I'm going to do is write those two numbers as an ordered pair, 2, -1. And that's how you solve a system, a 2x2 system, using a Cramer's rule, which is using determinants. The 3 by 3 gets a little bit more complicated. It's a little bit longer of a process, so I'm going to go over the steps of it now. So notice the first thing you're going to do is you're going to write out a bunch of matrices, and this is actually missing one. I don't know why that one's missing, but let me add it on. So matrix A is still the coefficient matrix, just like it was before. Notice the A, B, C, D, E, F, G, H, I. They're all the numbers in front of X and Y. Then as I go down, I'm going to start creating other matrices. Look at the first column. In matrix B, the first column becomes the constants. The second column and the third column stay the same as what they were before. When I go to matrix C, notice the constants move over to the second column. The A, D, and G stay. The C, F, and I stay. When I do matrix D, it's going to be the same thing. The A, the D, and the G will stay. The B, the E, and the H will stay. And the third column becomes the J, the K, and the L. So that becomes your constants column. When I figure out my variables, I'm going to take my numbers that I find for my determinants, and I'm going to divide them. X again is B over A, Y is C over A. When I do Z, it's going to be D over A. So let's go through a problem and see how this is solved using Cramer's rule. So the first thing I'm going to do, I'm going to write out all of my matrices so that I have what I need in order to do my determinants. So let's do matrix A first. Matrix A, all of the coefficients. So 3, -4, 2, 4, 1, -5, 2, -3, and 1. Matrix B. We are going to take and we're going to replace the first column with our constants, 18, -13, and 11, and the other columns get rewritten. Matrix C. My first column goes back to the original, 3, 4, and 2. My third column stays the same, 2, -5, and 1. The middle column now becomes my constants, 18, -13, and 11. Do the same thing for matrix D. My first column stays 3, 4, 2. My second column goes back to the original, -4, 1, and -3. Now my third column becomes my constants, 18, -13, and 11. So our job in this now is to find the determinant of every matrix that I just wrote down. Now remember, the determinant process for a 3 by 3 is a little bit more complicated than a 2 by 2. So the first thing you're going to do in every single one of these is recopy the first two columns. So let me do that. So after you've copied the first two columns again, now we're going to go through and we're going to draw our diagonals in, multiply our numbers, and figure out what our determinant values are. So as I go through and start multiplying, diagonal, diagonal, diagonal. So if I multiply the first diagonal, 3, 1, and 1 gives me 3. -4, -5, and 2 gives me 40. 2, 4, and -3 gives me -24. You're then going to multiply up the diagonals. First diagonal, 2, 1, and 2 gives me 4. -3, -5, and 3 gives me 45. 1, 4, and -4 gives me -16. So after I've gotten those values, we've got to add those values together, and then we're going to subtract them. So I get 19 in the first parenthesis. Second parenthesis, I get 33. And if we subtract those, we get a determinant value of -14. That number is going to be very useful as I go through and find the rest. So now let's go through and find the other ones. So again, diagonal, 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 and we're going to find those values, and then we're going to subtract what we get. So let me get a different color. So if I go diagonal, 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 when I multiply the first diagonal, I'm going to get 18. Second diagonal is going to give me 220. Third diagonal is going to give me, let me do it, 78. If I go up the diagonals now, first diagonal gives me 22. Second diagonal gives me 270. Third diagonal is going to give me 52. So again, we're going to add these numbers together. First parenthesis gives me 316. Second diagonal is going to give me 344. When I subtract those, I get a value of negative 28. We're then going to go to the next one. In the next matrix, again, we're going to do our diagonals. So down, down, down. 3, negative 13 and 1, negative 39. 18, negative 5 and 2 gives me negative 180. 2, 4, and 11 gives me 88. Then we go up the diagonals. First diagonal is going to give me negative 52. Second diagonal is going to give me negative 165. Third diagonal is going to give me 72. So our job is to add all of those numbers together. First parenthesis, negative 131. Second parenthesis, negative 145. And when you subtract those, remember subtracting a negative turns to positive, you get a positive 14. Now we're going to go through and do the last matrix the exact same way. First thing, diagonals. Diagonal, diagonal, diagonal. First one, 3, 1, and 11, 33. Second one, 4, 13, and 2. Going to get 104. Last one, 18, 4, and negative 3. Negative 2, 16. Go up the diagonals. First diagonal, 36. Second diagonal, negative 3, 13, negative 13, and 3. 117. And the last one, 11, 4, and negative 4. We're going to get negative 176. Again, once I've gotten those numbers, we're going to add them together. First parenthesis, negative 79. Second parenthesis, negative 23. Remembering that when you do a double negative, that turns to plus. So you get negative 56. Now, once I've found all of those determinant values, what do I do with them? In order to find x, you're going to do b divided by a. There's b, there's a. Negative 28 over negative 14, my x value is 2. To find y, c over a. 14 over negative 14 gives me negative 1. To find z, d over a. Negative 56 over negative 14 gives me a z value of 4. Once I have those values, I write the answer as a coordinate point. So my ordered triple, 2, negative 1, and 4. And there's your final answer. That is how you're going to solve a 3x3 system using determinants, which is called Cramer's rule. Make sure you write down any questions that you have. I only went over one example of each, so if we need to discuss more in class, please make sure that you make note that we need to do that.